Today we will be subtracting rational expressions, and let's take a look at our first problem here. Here we have two denominators, and they're exactly the same, and so we'll see that with the first two problems. And so the main thing I want you to do with the subtraction problems is change them to addition, and then it becomes a problem just like we did yesterday. So here the subtraction sign I'm going to change to addition. And notice that I change both signs to their opposite. So that's the key. So I'm going to circle that again, just showing you that this is what changes. I change the subtraction to addition, both signs switch to their opposite. So do that every time and you won't make as many errors. The next step is to collect like terms on the top of the fractions. So you always want to change subtraction to addition, switch the second fraction's numerator to its opposite signs, and then collect like terms if the denominators are the same. So here we have 3m and a positive 1m. So that makes 4m's altogether. And then count up the constants. You've got negative 6 and negative 2. So that makes a negative 8. Down below, we can just rewrite that denominator, m squared plus m minus 6. And so from this point we want to factor. So once we've combined it as one fraction, take a look and see if there's any common factors between these terms. So that's what I see on the top of the fraction. 4 is the common factor. Do the division, and I've got an m minus 2 left over when I take out that 4. Down below, no common factors, but it is a quadratic where it has the x squared term, or in this case m squared. And so it could factor as two binomials, and it does. M plus 3 and an m minus 2, multiply to make that negative 6, subtract to make the positive 1. So from this point we could take out those m minus 2's, and we're left with our answer of 4 over m plus 3. There is our answer. So we see the same thing, denominators are the same, so first thing I'm going to end up doing is changing this to an addition problem. So this subtraction sign to addition, these two signs to their opposite. And then from there we'll go ahead and combine this as one fraction. So you see the 5a and the negative 2a, I'll combine those to make 3a. I'll take this 2 and this 4, combine those, and I end up with 6. Down below I've got the a squared minus 4. And so now, once I've combined it, now is when you factor. So a common mistake is sometimes people, like right up here, they'll end up taking out the common factor of negative 2. And they might end up being able to reduce something, but then the denominators would not be the same. So you always want to combine it as one first and then factor out the common factors. So we take out that 3. When we do so, we've got an a plus 2 left over. Do the division, and I've got a binomial that is a square of two terms here, so it's a difference of squares they call it, and with factors down to an a minus 2 and an a plus 2. And then from this point we could go ahead and take out those common factors of a plus 2. Those will cancel, leaving us just with this 3 over an a minus 2. So now the problems get a little tougher because we have the different denominators. They look the same, m minus 3, but here it's a negative m and a positive 3. So first thing I would end up doing is changing it to addition. You just get in the habit of doing that. I think you'll make less errors if you do that. And so now I want to make them the same. So typically we'll change this one here, and we'll change it by multiplying it by a negative 1 over negative 1. And you see that will switch the signs of that denominator to match this denominator's signs. And so we'll go ahead and do that. So I've still got this 1 over m minus 3. I haven't changed that one. But now it's a plus positive 5 because the two negatives, they cancel out to make a positive. And here these signs will switch to an m minus 3. So now I can just add them together, 6 over m minus 3. So common mistake is people want to reduce the 6 and the 3, but don't get caught doing that. See, it's not really 3 on the bottom, it's 3 less than m. Let's take a look at the next one here. Same exact problem here as the last one, where you have same numbers, same variable and number, but opposite signs in the denominator. So first thing, change it to an addition problem, and then multiply one of them by a negative 1 over negative 1. So we've got this 2x over an x minus 1, and then it becomes a plus. This will become a positive again, positive x over an x minus 1. So we go ahead and collect like terms there, and we add these two numbers together because they're the same variable raised to the same power, so that makes 3x over an x minus 1. Now, again, don't cancel out the x's because it's not x on the bottom, it's 1 less than x. This one's a little different because you can't just multiply by a negative here. So first thing I'm going to do, subtraction to addition, change the second fraction signs to its opposite in the numerator. And so now I want to try to make the denominators the same. You look at the numbers first, 3 and 2, and this one here needs a 2. But also, before we go ahead and just multiply, look to see if you can reduce it all. See, this one has just 1d. I want to just have 1d if I could, and I can. See, I could take out this d right here and take out one of the d's on the bottom. I could do the same thing with this 2. So we could take this one out and this one out. So let's rewrite what we've got now. So what we've got is a negative 1 on top because of the minus sign, and 1 is left on top when everything cancels. So now I've got 4 over 3d plus negative 1 over d. So now, instead of having to multiply both fractions by some number, I could get away with just multiplying this second one by 3. And you see 3 times d will make the 3d. So what I've got now is 4 over 3d, and then I've got a plus negative 3 over 3d, and then from there I can just combine this as 1. So 4 plus negative 3 makes 1 over 3d, and that would be my answer. This one we're not so lucky in canceling as much stuff out, but I do see a little bit of canceling. See, I could reduce this by canceling out a 2, and I'm just left with an n there. So I have 5 over 3n minus 1 over n. So again, I could just multiply the second fraction by just 3, and that will make a 3n. And so I'll go ahead and also change it to an addition problem in just a moment. So 5 over 3n minus 3 over 3n. So let's go ahead and do that real quick. Change it to addition. And when I do that, this sign will switch. Combine like terms, I'm left with 2 over 3n. So another common mistake is people want to add the denominators, but you always keep the denominator the same because you're counting up how many of the denominators you have. Like for instance, if you had, let's say, 3 over 7 plus 2 over 7, you're counting up the number of sevenths you have. So here you have 3 sevenths. So it's like 1 seventh plus 1 seventh plus 1 seventh. That's 3 of them. Here we have 2 of those sevenths. So that makes 5 over 7 altogether, 5 sevenths. See, same thing here, counting up the number of 3n's that you have. Here we have 5, here we have a negative 3, so that makes 2 over 3n. So that's the first part. I'll give you some other problems in part 2 that are a little bit more difficult, and the denominators are a little bit more challenging to deal with. So check that part out.